In this video, we have a look at how to develop the formula for the area of a triangle, which is a half AB sine theta, using our basic rule, which is a half the base times the perpendicular height. So let's start by showing the perpendicular height within our triangle, and we'll do that with this dashed blue line and our right angle at the base. And our basic formula is a half base times perpendicular height to give the area. So we need to incorporate the A value somehow. So in the right hand side of our diagram, we know that sine theta is equal to the opposite side, in this case h, over the hypotenuse A. We'll rearrange that by putting the A on the left hand side. So we can substitute that into our area formula for h. So the area equals a half of the base multiplied by A sine theta. Now we can rearrange that so it becomes a half AB multiplied by sine theta. Now it's probably best to express that in words. It's easier to remember too. So the area of a triangle is half of the product of two sides and the sine of the included angle. So what happens if the angle theta is obtuse, as we can see here in this diagram? Once again, we'll create a perpendicular height, but in this instance it's outside of the triangle. And the angle that will form in the left-hand side will be 180 degrees minus theta. And we know that because we've formed a straight angle by continuing that dashed line, such that the whole straight angle is 180 degrees, and the angle in our smaller triangle will be 180 minus theta. So here's our basic area of a triangle formula, a half base times perpendicular height. And that's referring to our original triangle shown in purple. Now once again, we want to try and rearrange that using sine, this time of 180 minus theta, which is going to be equal to the opposite side h over the hypotenuse A. We'll multiply the A across, and we get sine of 180 minus theta multiplied by the A is equal to h. Now sine of 180 degrees minus theta is equal to sine theta, and you can check that out using a unit circle. So A sine theta is equal to h. We'll then substitute that into our original area formula to get a half b multiplied by A sine theta. And once again we'll rearrange that to get a half AB multiplied by sine theta, which matches our formula for the area of the triangle using sine of the included angle between two sides.